Kamarjoba. Well, that's the way we say hello in Georgia. Hello, children. How are you people doing? I'm Saurabh Kumar Dutt, and I'm here to teach you people a little bit of mathematics, wherein today we'll be looking up the ab initio method of finding out the derivative. Here we'll be looking up what is differentiation, what is the importance of differentiation, what are the different ways by means of which we can find out the differentiation except the method that we'll be talking about. Then where is it applicable in mathematics as well as at other places. Then we will also be talking about the geometrical meaning of finding out the derivative and why finding out the derivative at a specific point is very important. Now all of this is going to be laced with the culture of this lovely place that you see me standing in. This is Swaneti, Mount Caucasus, Georgia. It is a wonderful place where you can ski and walk about the winding trails, be in lush green valleys, mix up with the people who are really simple and down to earth, living in such villages which are worth a watch in your lifetime. So be here, have a nice time here, and I am gradually going to give you different informations about this place. Thus, this lecture is going to be laced with the culture of Georgia, which I'm sure you're really going to like, because here I'm also going to be telling you people about facts which are funny, that are to learn from. Then when you are tired with studying, I'll also be serving you people with a lovely sweet delicacy which I really like of this place, Georgia. Now children, remember, at the end, we will be discussing a sum, but that's not here. For that, there will be a link which will be there in the description. Do click the link in the description, then you will get to a sum which will help you understand all of this with the help of a sum, which is the practical application of the concept that we will be looking up here. So let's get started, children, and let's understand what is the process of differentiation and how we can benefit from finding out the derivative of a function. So if say we talk about the process of differentiation, we actually want to find out change in the value of the dependent variable with respect to the change in the value of the independent variable. So what is the dependent variable and what is the independent variable? For that matter, I'm sure you people must have seen functions like y is equal to x cube plus sine of x square plus 2x, right? Plus say log of 7 upon 2x, right? And functions like this which can have algebraic, trigonometric, inverse trigonometric, exponential or logarithmic functions, right? So such functions are y, that means y is the function in x, and that's why this y is also said to be f of x, which means that this is a function of x. So everything I'm sure you're able to understand is relying on x. If we don't start with some value of x, then you will not be able to proceed with the function. As such, x is the most fundamental entity here, or in other words, we can say that this is the independent variable, as it does not depend upon anything else, right? It is just like if you talk about certain units in physics, they are known as fundamental units. Like if you talk about the unit of time, or the unit of length, or the unit of mass, right? So they are the fundamental units and you can't do without it, and they are not dependent on anything, right? And then we have the derived units like the unit of velocity, the unit of momentum. They are all dependent on these fundamental units. Okay, so x is thus the independent variable, right? And as y depends on it, it is the dependent variable, right? So x is independent, right? And it's so good to be independent. I'm sure at the moment you people are under the rule of your parents, right? You have to do what your parents tell you, and thus you tend to feel that as I grow up I will get independence. But remember, what they are doing is also very nice, as the world outside will try to, chew you, and before that they just try to protect you so that you don't go in such ways which probably will give you certain bad habits or company of bad people. So that's why they try to keep you secure, and that's very important. Gradually they're trying to delegate this responsibility of things coming to you, right? So independent variable has a lot of independence, and I'm sure you're going to be having some sort of a feeling that it's independent and you are not. No, gradually you're going to get your independence. Okay, now when we talk about this y, this actually is your dependent variable, and it depends on the value of x. Okay, so now I'm sure you people are clear about what an independent variable and what a dependent variable is. Now when we try and seek the change in the value of the dependent variable with respect to the change in the value of the independent variable, we call this process to be differentiation. So next, now we're going to discuss something big, which is differentiation. Okay, don't use your pen at the moment, right? As that can be done a little later. Okay, because the moment you pick up your pen, then what will happen is your attention will get diverted, right? So at the moment, just listen. I will give you a second explanation, and then you can pause the lecture and copy all of this. Okay, so when we talk about differentiation, like I told you people, we have differentiation to be the change in the value of the dependent variable with respect to the change in the value of the independent variable, and it is represented by many variables. So let's talk about those variables. The basic that you will find out is it's going to be dy upon dx, right? It is also written like f dash x. It is also written as f1x. It is also written as y1, right? And then it is also written as delta y divided by delta x. But in this there is a speciality that delta x should be infinitesimally small, right? And what does that mean? That means that you should have the value of x to be really small, and normally when we talk about this value of delta x, it is also represented by h, as in times to come I'm going to tell you. And further, its value approximately is 10 raised to the power minus 4, or approximately 1 upon 10 raised to the power 6, as you know that this is also going to become 1 upon 10 raised to the power 4. So it is something which is pretty small, and as the need be, right, then this variable can be further taken to be further small, right? So normally you can expect that the value of h is pretty small in accordance with the normal things that we deal with, and thus it is 1 upon 10 to the power 4, or 1 upon 10,000, or 0.0001, right? Okay, so these are the ways by means of which you talk about the variable which actually defines differentiation. Now, how do we write differentiation? So whenever you talk about differentiation, that is dy upon dx, then you actually want to say that limit of h, remember h is the same as delta x, or change in the value of the independent variable, is infinitesimally small, right? And then if you talk about f of x plus h, right, from which you subtract f of x, excuse me, then here you will get, by dividing it by h, the derivative of the function or the differential coefficient of the function, right? Now children, here this does not have any meaning because we are talking about this generally, right? And that's why we require to bring in some specifics so that we can find out the derivative at a specific point. For that matter, here I'm sure you're able to understand that whenever we talk about y, we have talked about it to be f of x, right? And thus, if you're talking about f of x plus h, we are talking about a value which comes of the function at a later value of the domain. That means at a value of the domain which is a little after a specific value, right? And this is an earlier value of the function, right, at a point which is earlier than x plus h. And the difference between x plus h and x is actually h, right? So thus we are talking about the change in the value of the dependent variable, that is y, with respect to the change in the value of the independent variable, that is x. Now further to explain this, like I told you, this becomes a little meaningless unless and until we talk about a specific point. So let us now assume that we want to have this at, say, some point which is c, right? Let x is equal to c. So at the point c, you want to find out this change in the value of the dependent variable with respect to the change in the value of the independent variable. Then further you're going to write this as the derivative dy upon dx, which is going to be limit h tending to 0 f of c plus h, right, minus f of c, which is divided by h, right? So at the point c, then if you want to find out the change in the value of the dependent variable with respect to the change in the value of the independent variable, then you will say that this is the differential coefficient of the function at the point c, right? Now children, let's quickly understand all of this once more so that whatever is withstanding, whatever is something that you've missed out or that you haven't been able to understand, we will rediscuss it. As such, all of that will get clear. Moreover, this discussion is very important, the second discussion, because that really removes all confusion. So make sure that you always look up to the second explanation. So something special about Georgia before we continue with this. Now, do you know that Georgia is a place where you have 500 different species of grapes? Yes, you've heard me correct. I'm sure you just must have seen two types. One is the green grape and the second is the blackish, or you can say the plum colored grapes. But here in Georgia, there are some endangered species of grapes as well. For that matter, there is something on the lighter strain that Georgia is known for its wineries, or in other words, it is a country where the wine is very special. It's known as one of the world's famous wines, right? And you know that this was found out accidentally. I'm sure you people won't imagine it, but it did happen that there was an accident that some grape juice was kept in the severe cold winters in earthen vessels under the earth. And when it was taken out and had, then people started getting intoxicated, and then they understood that this is actually wine, right? And that is how wine was invented around about these places. And today the Georgian wine is very famous, right? This doesn't mean that I'm asking you to start having wine, right? This is just a fact that I'm telling you. Okay, so now children, let's quickly discuss further. Now if we talk about differentiation, we talk about two variables primarily. That is one, which is the dependent variable, which is dependent on another variable which is independent. That is, x in a function is an independent variable. You can keep whatsoever value of x that is possible, and correspondingly you get the value of y, which is f of x, right? And this process, children, of finding out the change in the value of the dependent variable with respect to the change in the value of the independent variable is known as differentiation, right? So here we talk about the different notations of differentiation, that is dy upon dx, f dash x, f1x, y1, right? Then it is also written like limit delta x tending to 0, right? Delta y upon delta x, right? This is another symbol of differentiation. After this, children, we talked about the actual way by means of which we talk about the process of differentiation. So whenever we are interested in finding out the change in the value of the dependent variable with respect to the change in the value of the independent variable, right, this d actually shows that the change in the independent variable is infinitesimally small. As such, it will bring in some very small change in the value of the dependent variable, right? And that's why we use this d in place of delta of Greek. Now this delta is something which shows change, and I'm sure you must have seen this when we find out the slope of a straight line. We talk about y2 minus 5 upon x2 minus x1, which is also written as delta y upon delta x, right? So here thus, when h is infinitesimally small, and h is what? H is actually delta x, or change in the value of x, then we talk about the difference f of x plus h minus f of x, that is the change in the value of the dependent variable, divided by h, which obviously can be said to be that it is x plus h from which you subtract x, right? And thus we are talking about the ratio of the change in the value of the dependent variable with respect to the change in the value of the independent variable when the change in the independent variable is infinitesimally small. And I told you that when you talk about a quantity which is infinitesimally small, you mean that that is really small, of the order of 0.0001 or probably 0.00001, right? So further, if it is required, more smaller values can be taken in. Now children, when we talk about the process of differentiation, it loses its meaning in practical sense unless until you find out for a function at a specific point. For that, we've taken the point when x is equal to c. And now when you talk about dy upon dx, it becomes equal to just x to be replaced by c, as x is equal to c. So limit h tends to 0, f of c plus h minus f of c divided by h will become the derivative. And remember children, when we find out the derivative by this method, it is known as ab initio, right? So if in an examination you're asked to find out the derivative, right, by ab initio, you understand that it is by the first principle or by this formula, right? Okay, don't make a mistake of writing PAL. That's actually the principle of your school, right? Now, principle or a concept is always PLE. Right, so this was about the definition. Now let us quickly understand where is it that you require differentiation. Now if say we talk about velocity, right, don't you talk about velocity to be the change in the distance which is divided by the change in time? That is, you talk about the distances changing, right, with respect to the change in time. That means in a specific time, how much amount of distance has been covered, right, in a specific direction, right? If you talk about speed, then obviously you're not going to be concerned about the direction, but if it is velocity, it should be in a specific direction, right? Okay. So in other words, you can say that when you talk about this s which is in the numerator, as this is distance traveled in a specific direction, it is the displacement that you're talking about, right? So the change in displacement with respect to time is going to be the velocity, right? And now thus, if you talk about here another thing, that is this change, that is the time, that is the independent variables change to be really small, right? Then we can say that we have something which is infinitesimally small, and in that case then we will talk about the velocity to be instantaneous velocity. That means it's a velocity which is just at a specific instant, right? For that matter, now if you talk about the instantaneous velocity, right, then the instantaneous velocity will be given by limit delta t tending to 0, and then you talk about the change in the displacement with respect to time, right? So this is how in different physical quantities we tend to differentiate, right? And then you get different values. Okay, so like I gave you this example, if you require the instantaneous velocity, then you require to differentiate the function of displacement with respect to time, or in other words, you can thus say that this can then be written as d divided by dt, or in other words, we want to find out the change in the value of the displacement which is changing with respect to time. Okay, now children, let us try and understand what is the geometrical meaning of finding out the derivative of a function. So let's say we have a function which is, say, some y is equal to f of x, and of this function, if you try and draw a graph in 2 dimensions, that is in xy plane, then probably we can have the graph to be, say, something like this. That is, you have, say, this to be your xy axis, right? This being the positive direction of the x-axis, right? And this being the positive direction of the y-axis. Now let's say when you talk about drawing a graph of a function, let's say it comes out to be, say, something like this, right? And when you have a specific point on this curve, let's say some x is equal to c, at which you want to find out the derivative of a function, it means that you want to find out the slope of the tangent at that point. So next, now we'll be talking about drawing a tangent, right? And a tangent drawn at this point is somewhat going to look like this, right? At the moment it has become not a tangent but a line which is intersecting, so I will try and make something different. Okay, so trying again, it has to go like this. Okay, so this, children, can be said to be a tangent to this graph at, say, some x is equal to c. For that matter, if we want to show that this is happening at x is equal to c, then we can just drop a perpendicular to the x-axis, and that will then become the graph, right? So I'm sorry, it will become to be showing the point at which you want to find out the derivative. So this is x is equal to c, say, right? Because this distance is the distance along the x-axis, right? So at x is equal to c, you have this tangent, right? And if you want to find out the slope of the tangent, remember we were representing the slope or the gradient by the letter m, right? So m that we were talking about was what? It was delta y divided by delta x, right? Or in other words, it was y2 minus y1 divided by x2 minus x1, that is change in the value of y divided by change in the value of x, gave you the slope. Now how does it come from here? That is now what we're going to look up next. So now, children, if, say, you talk about, say, the process of differentiation where we are finding out the derivative at x is equal to c, then we're doing what? We are doing this to be limit h which is tending to 0, we are talking about f of c plus h, from which is subtracted f of c, and that is going to be divided by h, right? So here, children, just note, if you talk about this, then this is limit h which is tending to 0. Here in the numerator we have some y2, from which we are subtracting y1. That is, c plus h was the value of the function at a later point, and f of c is the value of the function at c. For that matter, let us quickly mark this on the curve as well. So if, say, we now talk about the point which is c plus h, we can consider a point which is very close to c, right? And on the right side of it, although in times to come you will get to see that we also talk about the value of this h to be on the left hand side. So it can either be on the left hand side, or it can even be on the right hand side, right? So here, thus, we can have this point which is distant h, that is infinitesimally small distance, right, to be either on the right side of it or on the left side of it, right? So this distance, right, is what? This distance is h, right? And similarly, this distance is also h, right? And here, if you talk about h on the right side of x is equal to c, then here we will say that h is tending to 0 plus, as it is positive distance from c. That means if we add it to c, we will move on the right hand side of x is equal to c. And for the left hand side, we will say that h is such that it is tending to 0 minus. That means it's a infinitesimally small number but negative. So when added to c, obviously it will take you to the left hand side of c, right? So at the moment we are just dealing with a neutral 0, right? That is, h is tending to 0, and we're just trying to understand what the derivative means geometrically. So here, if you look up, this actually comes out to be this. That is, we have here different values of y, one which is beyond c and one which is at c, where h is actually c plus h, from which if you subtract c, you will get to h, right? Just look up here. If, say, you talk about this h, this can be written as c plus h, from which you subtract c, right? Thus, you can say that this is the latter value of x, that is, it is x2, from which you have subtracted x1, which is the earlier value of x, or the independent variable. And then you will get what? You will get the difference of the y coordinate, or the function, divided by the difference of the x coordinate, that is the independent variable. And in other words, I'm sure you're able to understand that this delta y upon delta x actually represents the slope, and thus you can say that this is actually the slope. And it is the slope of what? It is the slope of this tangent, because at x is equal to c, this is the tangent which has been drawn. So in other words, you can say that this is actually the slope of the tangent. Now, some people will say that, why is it that I will consider that this is the slope of the tangent? This can be the slope of anything else. That's because when you talk about the value of the function at x is equal to c plus h, it was somewhere here. And if you talk about the value of the function here, then it was the value of the function at x is equal to c. And because this small distance is infinitesimally small, thus this can be considered to be the same point, right, at which you're wanting the slope of this function, right, because you are differentiating the function, and that is why this gives you the slope of that straight line, which is formed on this point x is equal to c, and is just touching the curve at this point, because this distance is infinitesimally small, right? So thus we can say now that we have the slope of the tangent, which is given by finding out the derivative of the function at a specific point. Now all of this that I discussed, I will just quickly discuss again with you people. Now remember children, we discussed about this to be finding out the derivative of a function by ab initio. So we have dy upon dx, and that's equal to limit h tends to 0 f of c plus h minus f of c divided by h, right? And this is the ab initio, or the first principle of finding out the derivative of a function, right? Practically it has applications, like if you talk about finding out the velocity, it is change in displacement with respect to time, right? So if we talk about it to be infinitesimally small, then it will give us the instantaneous velocity, that is limit delta t tends to 0 delta d divided by delta t, or in other words d upon dt of the function d, which is in terms of t. Now children, further I told you people about the geometrical representation and the geometrical meaning, and here when we talk about the geometrical meaning, then it shows us that when we find out the derivative, we are actually trying to find out the function's graph first made, then at a specific point when we talk about the derivative, then it is the slope of the tangent at that point. And that is the reason why I told you why when we talk about the formula of finding out the derivative, that doesn't have any geometrical significance unless until we talk about a specific point, right? So we have at the point C the formula of finding out the derivative by ab initio to be limit h tends to 0 f of c plus h minus f of c divided by h. This h can also be written to be c plus h, from which c has been subtracted. That means from a later value of x, the independent variable, that is c plus h, when you subtract x is equal to c, then obviously you will get to h, and this h is the infinitesimally small distance between x is equal to c and x is equal to c plus h, right? So thus we can say that this is actually delta y divided by delta x, or in other words it's y2 minus y1 upon x2 minus x1 when this change in the value of the independent variable is infinitesimally small, right? And that actually is the formula of finding out the slope, right? And this is the slope of the tangent which has been drawn at this point x is equal to c. And why is it that this is the slope of this tangent? That is because when you talk about the straight line which can be drawn, at the point which is x is equal to c, it is going to be the join of 2 points, one which is the value of the function at x is equal to c, and the value of the function which is at x is equal to c plus h. And as you know that the join of 2 points is a straight line, and since this distance is infinitesimally small, right, this will come out to be just at a single point, that is x is equal to c, and thus this gives you the slope of the tangent at this point, right? Okay, now that you've understood that this gives you the slope of the tangent, now I'm sure all of you people might be having this interest to quickly copy all of this. So I like you people to quickly copy all of this, and I'm sure all of this you want to understand with the help of an example wherein I discuss a sum, right, as to how it is to be done by the ab initio method. Now something more interesting about this place, this is the place where Swan people live, who were warriors, who were known for ultimate bravery, keeping their word, and such things which have just become, you know, things that we can just hear of, right? Very few people follow all of this. So this is such a special place. Then this place which is at a very high altitude, and it is considered to be a place where one of the highest altitude villages actually exist, right? And this is a rugged territory which is marked by green valleys and winding roads, right? I'm sure in which you will really like to trek. Okay, now children, more about this is going to come over in the next part of the lecture, and for that what you require to do is you require to click on the link which is there in the description, right? And then you will get to that lecture where I discuss a sum with you, right, which I'll show you, right? So this sum is going to be discussed when you come over by clicking on the link, right? And then you'll get me on the other side doing the sum with you and explaining the finer concepts, and obviously then we will also be having more about Georgia, right? Some really funny things, some things really to know about, and I'll also be serving you people the sweet delicacy which I really like. Bye children, have a nice time, and meet you people on the other side where you will come and look up the sum to understand more. Bye.